Hey, engineering students, Mr. Ekstrom here. We're going to today start taking a look at how to use Arduino as a engineering prototyping tool. This is for remote students who don't have access to an actual Arduino and can't use an Arduino driver on Chromebooks. And so we're going to use a simulation called TinkerCad to help us out. And today will just basically be an introduction to Arduino, basically how it works, a little bit of a review of electronics and how to use a breadboard, and then get you into TinkerCad. We're going to build a couple of simple projects, and when we're done with this, hopefully we can be ready to embark on some more complex Arduino projects. So at first we're going to just get to know your tools that you have available. This should be a little bit of a review. We've got some circuit elements here, the symbols, and some actual pictures, diagrams of the types of devices that we're going to be using in this first project. Battery, we're not going to use a battery probably. We're going to use Arduino as our power source because it can do that. But there's the symbol for a battery right here. It's just two lines. Sometimes it's more than two lines, but they alternate between short and long, and the short end is the negative end, the long end is the positive end. Here's a resistor. We're going to be using a resistor. Resistors come in all different sizes, and we'll be able to identify which types of resistors by the color code on the resistors. The symbol for resistor is just this squiggly line, which doesn't mean a bent wire, it means a resistor. We're going to use an LED. This is a circuit element diagram for a LED. It's an arrow with a block on the end because current can only flow in one direction in an LED or in any kind of a diode. Light emitting diodes emit light, and that's what the two little arrows coming off the top represent. So this is a symbol for a diode, but because the two arrows are there, it says it can emit light when current's going through it, so that means that it's a light emitting diode. And then a button switch. So this is a switch circuit element. It's just an interruption in an electrical conductor that when you push the button down, just literally like this symbol shows, you're making a connection between the two ends and forming that circuit, making it complete. One of the most important things to consider when you're using Arduino, or you're actually using anything in electrical circuits, is that you can complete a path from the high energy to the lowest energy part of circuit, the high voltage to the low voltage, or the positive on the battery to the negative on the battery. And your current is going to do that in the easiest way possible. So to get used to this, here's two ways to model the same circuit. Here you can see the battery symbol right there. That's a plus minus right here. Sorry, this is the positive end of the battery. Current will flow from plus to minus, so it'll go through here. And then if that switch is open, the only way that it can possibly go through would be through this resistor and then the LED, and then the light will light up. If the switch is closed, then there's an easier pathway for the current. Instead of going through the resistor and the LED, it can just go straight through the now closed circuit and go from positive to negative. And so that was what will happen. Over here on the right, we have an alternative way of expressing this, just a different kind of a circuit diagram. Think about taking this battery and splitting it apart between the plus and the minus, and then unfolding it so that the plus goes up and the minus goes down. So that's what we've got over here. This little circle, that represents the positive, and this triangle made out of decreasing size lines, that represents what we call ground, or the negative terminal of the battery. So this is just another way, when you're using the same battery, the same voltage source for a lot of different elements, it's just easier to draw it this way rather than having lots of branches going all over the place. So plus to minus, or high energy to low energy, current can flow down either of these two branches. If this switch is open, that's not a possibility, so current will have to flow through this branch, through the LED and the resistor, and then to ground, and so the LED will light. But if the switch is closed over here, then there's no reason for current to go through that more resistive pathway through the resistor and the LED. It'll just go down this branch and then straight around to ground and just bypass the LED, and so you would turn the LED off by pushing the button down. So that's a kind of a thing that we do a bit in electronics and in digital prototyping. So this is just a review of that. If the switch is open, current will flow through the LED because it has to. If the switch is closed, it has a better least resistance pathway to ground, and so it'll go that way and not light up. This is a breadboard layout. This is probably a review for you, but here's what a breadboard looks like at the top. It's a series of holes. If you could use X-ray vision and look through the plastic top of the breadboard, this is what you'd find. The two rows of holes on the top and the 2 rows of holes on the bottoms, they're connected to each other. Those we call those rails a lot of the time. So that means that all the holes in that top rail are connected to all the other holes in that top rail. And then all the holes in the second rail are connected to all the other holes in the other rail. So you can make a connection between 2 wires by just poking them into any two of those holes. Now the first rail and the second rail are not connected to each other. On the bottom you have the same thing. 2 rails that are not connected to each other, but all the holes within a rail are connected to each other. Then in the middle, in the field here, we have lines of 5 holes that are all connected to each other. If I wanted to connect 2 wires, I could poke 1 wire here, and I could poke another wire here, and those 2 would be connected to each other. But this row of 5 holes and the neighboring row of 5 holes are not connected to each other. The other side of the board is a mirror image, so you have another set of 5 holes, but these 5 holes are not connected to these 5 holes. There's this thing in the middle, I call it the ditch. It's a physical separation. It's just a plastic, a hole in the plastic, sort of a ditch in the plastic that disconnects these holes from each other. But if you jump across that ditch by putting a circuit element across the ditch, then you can connect them. So that's what's underneath a breadboard, and you need to kind of keep this map in your head as you use a breadboard to build circuits. So TinkerCad is what we're going to use to simulate our Arduino projects, because you guys do not have an Arduino available or the ability to drive it. So this is a simulation. It actually does very, very much like what a real Arduino would do, with a slight advantage that you can never screw up any wiring connections as long as they go to the right places. You'll never have a loose wire because the wires are all virtual. So it makes it a little bit easier to troubleshoot things when they're going wrong. So I'm going to show you how to get to TinkerCad. You'll have to create an account there. And then from here on, a lot of what we're going to do will be just using TinkerCad as our fake Arduino so we can learn about digital prototyping. To get started, you want to go to tinkercad.com. TinkerCad is just spelled Tinkercad, and create an account. So you don't there's no like learning code, or you're not signing up to be a student in a class. We're just tinkering around. We're just using this as a simulation tool. So as you're signing up, just put in you can probably put in your school email or your personal email. It probably doesn't really matter. And get yourself an account. It's a typical kind of a thing that you'd sign up for an account. It's free. And then when you go to TinkerCad's dashboard, once you get an account, there'll be a little bit of stuff over on the side here. We're interested not in 3D designs or code blocks or anything like that, and we don't want to use any of the pre-canned lessons. You just click on circuits, and then it says try circuits. If you click on try circuits, it just takes you to the circuit simulator and says start simulating. And then there's probably a little tutorial, but you can sort of ignore that because I'm going to give you a lot of the information that you need. So here's the basic layout. Here's a workspace where we can virtually build things in here in TinkerCad by dragging components onto the screen here, the workspace. Like for example, I can take a breadboard and just put a breadboard onto my workspace. It gives it a name. If default name is 1, but I could name it something if I wanted to. And I can put a battery on here if I wanted to. I could drag that on. What I want is an Arduino, so I can drag an Arduino on there as well. So this is just like the kind of Arduinos that we're using in class. It's an Arduino Uno. It's the kind of a standard beginner Arduino prototyping tool. You can see that there's a little USB connector here. When we start a simulation, that will actually plug in as if you were plugging into the computer and downloading a program to the Arduino. When you want to make a connection, you can just connect some wires. So let's say I wanted to have that simple circuit that just goes through a resistor and an LED. I can take do a look through the components here. There's basic components, all components, Arduino, microbit, circuit assemblies. There's a lot of different like indexes of components. I'm going to go in basic, and I'm going to grab LED, and I'm going to drag an LED on here. Now, if you look at the LED, you can see that one side is sort of bent, the other side is not. If you hover over it, the bent side is the anode, that's the positive side, and the non-bent side is the negative side of the diode. Remember, diodes are directional, so we want to make sure that we know that the plus side is there and the minus side is there. So my Arduino, one of the things that it has on it is a 5-volt voltage source. You can see down here it says 5 volts. I'm going to connect a wire by just clicking on that little pin, and I'm going to stretch this wire to the plus rail on my breadboard, and then when the holes light up, then I'm going to just click there. So now I've made a wire that connects my +5 on my Arduino to the breadboard. Positive is usually red, so I'm going to just change the color of that wire to red by using the little pull down there. And then I want to also ground this or make the negative connection as well. So I'm going to click on the GND right next to it. That's short for ground. So that's the negative terminal. And I'm going to drag it to the minus rail and click. And black is usually negative, so I'm going to change the color of that wire to black. So now there's power to both of these rails. So anything I connect to this rail right here that the red wire is connected to, that's going to be +5. Anything I connect to the other rail, that will be ground or negative. So I want to put a resistor on here to protect my LED. So I'm going to grab a resistor, I'm going to drag it on here, and I'm going to plop it down in a place where it connects from the positive rail, right there, to one of the 5 holes where the cathode is. Sorry, I've done this wrong. I want to connect to the anode because I connected to the positive rail here, so I'm going to click it over one click. So the anode is on this side, that's the positive side. And here's my resistor. So current flow is from the Arduino, through the positive rail, through the resistor, and then it would go through the LED if it had a pathway to home. I want to specify what this resistor is, and I can do that. I guess before I put the resistor on the board, I need to specify what the resistance is. Right now it's set at 1 kilo ohm. I'm going to make this a 220 ohm resistor, so I'll key in 220, and then I'm going to change the unit from kilo ohms to ohms. So this is a 220 ohm resistor, and then I'm going to bop that in place between the positive rail and the anode of my LED. Now I make one more connection, and that is I have to connect the cathode, the negative side, to the negative rail of my breadboard. So I'm going to make a connection between those two places. I'm going to turn that black, and now I have a circuit. I'm going to simulate what would happen if this was a real Arduino by clicking on Start Simulation. The LED lights up as the USB port plugs in and powers the Arduino, and the Arduino gives power to the circuit. So current is now, in this simulation, currently flowing from the positive terminal, the 5-volt terminal, through this rail, through the resistor, through the LED, back to the negative terminal, and then back to ground on the Arduino. And so we've got our circuit. Click Stop Simulation, the light goes off, and it unplugs the Arduino. Let's add something else. I'm going to take this connection here, this wire, and I'm going to get rid of it. And I'm going to add a push button switch. So I'm going to put a push button, I'm going to put it right here. I'm going to have my resistor flipped over to the anode side, or cathode side, and then scooch it up one so that it's connected to ground. So I'm just moving the resistor to after the LED instead of before it. I'm going to connect from positive to the input to this switch. So I'm going to go from the positive rail to right there. I'm going to make this red because it's positive. And then coming out of this switch, I'm going to go over to the anode of my LED. So connect from there to, I'm going to click right on that hole right there. So now, when the switch is open, which is right now, the switch has not been pressed, current can't flow through the switch, so nothing is happening. If I were to press the switch down, I now make it possible for current to flow from the positive rail through the switch, through this red wire, through the LED, through the resistor, and back to the ground rail, so the LED should light when I push the button. Start the simulation. Nothing's happening, even though the Arduino is now powered up. When I push the button, it lights up the LED. When I let off the button, it unpowers it. So what we've done here is we've just used the Arduino as a source of voltage, a power source. But the Arduino is way more capable than that. It can do many more things than just serve as a kind of an expensive battery. So what we're going to do next is tap into the programming power of this Arduino. And I'm going to disconnect this for right now. I'm just going to take these wires off and sort of ignore that breadboard for the moment. On the Arduino, there is right here labeled L, this little LED that's built in. That LED is connected to this pin 13 right here, which you can actually connect wires to. And whatever's happening on pin 13 is reflected by what's going on with this light. So you can turn the light on and off by programming it. So I'm going to show you how to write a little bit of code. So you go up here and click on code, and then the first thing that opens up is blocks. We're going to use actual code, so just go to text. And now what it actually did here is it gives me some code that I probably could use here as a starting point, but I'm going to take that code out so I can show you how to write code. Now, in an Arduino sketch, that's what the name is for these programs, there are two things that always must be present. One is called the setup, and the setup happens one time as soon as you start the Arduino and load this sketch onto the Arduino. And then you have something that's called the loop, and the loop runs continuously over and over and over and over again until you change the sketch or you run out of power or disconnect it from its power source. So every sketch, every program that runs on Arduino has those two elements. And here's how you set them up. First, you type the word void, and then for setup, you're going to do setup, and then open parenthesis, close parenthesis. And then you open up a bracket, a curly bracket. So it's saying everything that's inside these curly brackets, we're going to do this one time when we first hook up the Arduino. Now in this particular program, here's what goes in our setup. It's just one line. We're going to use a command called pin mode. So it's PIN and then capital M ODDE, pin mode. And you have to spell this exactly the right way so you have the correct syntax. And then a parenthesis. And then in all caps, we're going to go LED underscore built in, which is pin 13, comma, and then all caps output. And you have to spell everything right or the Arduino can't read what you're which you're laying down. This is an actual command, a line of code, so we're going to put a semicolon after it. So all commands that tell the Arduino to do a specific thing end with a semicolon. This is the end of setup, and so we're going to close curly bracket to tell Arduino this is the one thing that you do when you first start up the program. Okay, next is the actual loop that does what we want it to do. So we do that by typing void again, and then loop. And then open paren, close paren, and then open curly bracket. So this is the code that's going to run over and over again on our Arduino once we start. It's a loop. It's just going to loop over and over again. So our loop is going to have 4 lines in it. The first one is called a digital write. So we go digital, and then capital W write. And you have to spell everything right. Digital write, and then open parentheses, and then the digital write has 2 parts to the command. The first one is, what pin do you want to write to? In other words, what thing do you want to change? And what we want to change is the LED built-in. So we're going to type LED underscore built-in. And again, it has to be all caps, and you have to spell it right. And then a comma, and then after that, how do we want this thing to be written? And we're going to type the word in all caps, high, which means turn it on, basically. Give it a plus 5 volt signal. So that's a line of code. We end it with a semicolon. Oh, I should explain something. Up here in our command for pin mode, what this is telling us is make LED built-in a pin, and, well, it's already a pin, but it's saying specify this as an output, not an input. So Arduino can take signals from the outside world, and it can send signals to the outside world. So you have to specify if if a pin is an input or an output. So Arduino knows what to do at that pin. And I should show you another thing. If you do double backslash, you can put a comment in here that Arduino will not read, but human beings can read. So it can be a note. So I could just type in here sets built-in pin as output. And here I can spell bad if I want to, because it's not code that's going to actually be read. I'll do the same thing here. I'll just put a note here of what this does. It says turns on built-in LED is what that line of code does. So because there's double slashes in front of this thing, it means it's going to ignore that when it runs the program, because it knows it's only for humans. Okay, so my next line after the digital write LED high is I'm going to delay for a second. So I go delay, and then in parentheses I'm going to put 1,000, because Arduino counts in milliseconds unless we tell it otherwise. So this says delay 1,000 milliseconds. So wait a second. So I put a comment in there. And then we're going to turn the LED off. So that's a digital write. So LED underscore built in. And then the word low. And as you start writing sketches on your own, you'll realize you can save a lot of time by just cutting and pasting, because a lot of commands are very similar to each other and you just have to change one thing. So what this does, this line of code, turns off the LED. And then another delay. We're going to delay for another second, so delay 1,000. And that's the end of our loop, so I'm going to close curly bracket. So what this thing does is, as soon as we load this sketch, it's going to say, okay, LED built in, we're going to set that as an output. It's going to do that once. And then it's going to run this loop over and over again. So it's going to turn on the LED, wait a second, turn off the LED, and then delay for a second, and then do it all over again. Okay, so now let's move the code off the screen just so we can see a little bit better. And then we'll click Start Simulation. Oh, I made a mistake. So I have to find out what it is. A stray slash in program. And it's seeing it in multiple places. Slash is in the wrong direction, I think. Another problem? Oh, here it is. Okay, there we go. It ran. So that's very common. It's easy to make a little mistake, and every mistake that's flagged by the program will prevent you from being able to run your code. Now, if you look at the Arduino, you can see that little L light is blinking on and off. So it's happening. Is running the code, and it's looping. It's on for a second, off for a second, on for a second, off for a second, and it'll just keep doing that forever or until we stop it. So let's stop the simulation, and now let's just modify a little bit so that we can interface with the outside world. So going back to the breadboard here, I'm going to take this switch and get rid of it. Don't need it anymore. I'm going to get rid of this wire. Don't need it anymore. And I'm going to get rid of this wire because I don't need it anymore. Now what I'm going to do is I'm going to attach, instead of the positive rail, I'm going to move my code out of the way. Instead of the positive rail being attached to my anode, I'm going to attach it to pin 13. So I'm going to hook a wire from here and poke it right into pin 13. So now current will flow from pin 13 when it's told to, through the LED, through the resistor, and back to the ground rail. But the ground rail isn't hooked up to anything. So now I have to connect my ground rail to Arduino ground. So I'm going to run a wire from here, any one of those rail connector points, to the GND, or any of the GNDs. There's 3 of them on my Arduino. And I'm going to make that black because it's negative. So now we have kind of a complete circuit. Let's go to our code again, and let's just change it a little bit. Let's change it from LED built-in to pin 13. So I'm going to change LED built-in here to 13. And I'm going to change this to 13 as well. So now the internal LED, because it's pin 13, the internal LED will still blink every second, but now our LED on the breadboard should also blink. Let's see if it does. So let's start the simulation. So you can see the LED on the Arduino is blinking, but in sequence, just right in time with that, is also the LED that's on the breadboard blinking. Stop the simulation. Just to show you how this is kind of flexible, let's just move this to a different pin. Let's move this to pin 7, and then we'll just change our code from every place we see a 13, we'll change it to a 7. Start the simulation. Now the built-in LED isn't blinking, but the LED on the breadboard is blinking. Okay, so that's your first sketch, the blinky light sketch. I encourage you to play around with this and build this, write your code, and then modify your code. See if you can make it blink faster, blink slower, move it to different pins. Just experiment a little bit and see what you can do.